Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about spectroscopy, especially UV visible spectroscopy. So what is spectroscopy? Spectroscopy is a necessary tool for structure determination. Organic chemistry uses spectroscopy as a necessary tool. The first spectroscope was invented in 1859 by a German chemist and German physicist. Spectroscopy may be defined as the study of the quantized interaction of electromagnetic radiation with matter. Now in this slide I will talk about difference between spectrometer and spectrophotometer. What is the spectrometer? An optical spectrometer, spectrograms or spectroscope is an instrument used to measure the properties of light over a specific portion of electromagnetic spectrum, typically used in spectroscopic analysis to identify materials. Spectrophotometer. A spectrophotometer is an analytical instrument used to quantitatively measure the transmission of reflection of visible light, UV light or infrared light. Friend, what is electromagnetic spectrum? The electromagnetic spectrum covers very wide range of electromagnetic radiation from cosmic rays to radio wave at the other end. The arrangement of all types of electromagnetic radiation in order of their wavelength of frequency is known as complete electromagnetic spectrum. Now friends, ultraviolet and visible spectroscopy. In this slide I will discuss about this. Ultraviolet and visible spectrum deals with the recording of the absorptions of radiation in the ultraviolet and visible regions of the electromagnetic spectrum. The ultraviolet region extends from 10 to 400 nanometer, near ultraviolet quartz region 240 nanometer, far or vacuum ultraviolet region and visible region extend from 400 to 8. You can see UV visible spectroscopy machine. The principle of UV visible spectroscopy. UV visible follow the Beer-Lambert's law. Beer's law: the intensity of beam of monochromatic light. Intensity of a beam of monochromatic light decreases exponentially with the increase in concentration of the absorbing substance. So Beer-Lambert's law: when a beam of light is allowed to pass through a medium, the rate of decrease of intensity with the thickness of medium is directly proportional to the intensity of light. So A is equal to ACF. The instrumentation's radiation source. Hydrogen discharge lamp is the most commonly used source of radiation in UV vision. The deuterium discharge lamp is used in place when the more intensity is desired. Monochromator, it disperses the radiations obtained from the source into their separate wavelength. Prism and grating made up of quartz. Detectors, these have photocell or photomultiplier tubes which generate voltage proportional to the radiation's energy that strike. Now amplifier. The spectrometer has balancing electronic amplifier which subtract the absorptions of effluent from that of the solution electronically. Recorder, it automatically records the spectrum as a plot of wavelength of absorbed radiations against absorbance or model absorptivity. You can see here the reference beam, simple beam, blank detector, simple detector, amplifier, recorder, UV spectrum. So sample handling. UV visible spectra are usually recorded either in very dilute solution or in the vapor phase. The sample is dissolved in some suitable solvent which does not itself absorb radiation in the region under investigation. Commonly used solvent are cyclohexane, 1,4-dioxane, water and 95% ethanol. The chosen solvent should be inert to the sample. Theory of UV visible spectroscopy. UV visible absorption spectra originate from electronic transition within the molecule. This transition involves promotions of valence electron from the ground state to the higher energy state are called electronic transition and caused by the absorptions of radiation energy in the UV region of the electromagnetic spectrum. Since the various energy level of the molecules are quantized, a particular electronic excitation occurs only by the absorption of a specific wavelength of radiation corresponding to the required quantum of energy. So electronic transition, sigma sigma star transition, n to sigma star transition, pi pi star transition, n to pi star transition. This is the pictorial diagram. Now friends, formations of absorption band. Since the energy required for each electronic transition is quantized, the UV-visible spectrum is expected to exhibit a single discrete line corresponding to electronic transition. Broad absorption band are usually absorbed. So designations of absorption band, you see K band, R band, B band and E band. K band pi pi star, R band into pi star, B band pi to pi star, E band pi to pi star. So you can see absorption intensity shift, barochromic shift, hypsochromic shift, hyperchromic shift, hypochromic shift. So application of ultraviolet and visible detection of functional groups, chromophore, detection of conjugated and elucidation of its nature, a study of extent of conjugation, distinction between conjugated and unconjugated compound, a study of strain, determination of configurations of geometry isomer, a study of tautomism, conformations of expression, suspected phenol and aromatic amine, a study structural feature indifference of them. So friend, hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.